welcome to Illinois Groundwork. This is a web-based resource. It contains research and tools to optimize the design and planning of green stormwater infrastructure in communities and cities. My name is Mary Pat McGuire, and I'm Associate Professor of Landscape Architecture at the University of Illinois. It's my pleasure to introduce to you Dr. Drew Phillips. He's a Senior Research Scientist at the Illinois State Geological Survey. And Drew is going to talk about quadrangle maps. He's going to talk about the resources, the map resources that are available through the ISGS, but he's going to focus on quadrangle maps, what they are, what kind of information is contained in them, how to find them, how to read them. And he'll walk you through some examples focusing on the Palos Park Quadrangle in Southern Cook County. And he's going to talk about the different soil types that are mapped in those quadrangle maps, and to understand different properties of those soils and how they functionalize. And actually, they serve a great role in the way that groundwater and surface water that comes to us through different rain events interacts with those soils. And so it's incredibly useful knowledge and tool in a preliminary stage of understanding the soils context in any area where green stormwater infrastructure is being planned.
Hello. One of the flagship enterprises of the Illinois State Geological Survey is the construction of geologic maps of Illinois. When printed on a sheet of paper, these maps range in scale from the highest resolution of so-called quadrangle scale, that is 1 inch is about 2,000 feet, to county scale, about 1 inch to the mile, or statewide, about 1 inch to 4 or 8 miles. These maps can be found on the ISGS website. Right here, I click on Maps, and this video will focus on our highest resolution quadrangle maps. They are formatted on the United States Geological Survey 7.5-minute quadrangles, that's 7.5 minutes of latitude and longitude. And Illinois, these are about 10 miles in the north-south direction by 6 miles east-west. The base quadrangle maps can be downloaded from the USGS National Map site. In addition, important information that goes into these maps, such as high-resolution LiDAR and air photo data, can be downloaded from the national map, as well as from the ISGS Illinois Geospatial Data Clearinghouse, which can be found right here. And one can find all manner of data on the Illinois Geospatial Data Clearinghouse. So let's go straight to the maps. From the ISGS website, we've already clicked on quadrangle maps, and you can see that most of Illinois is not covered by these higher resolution maps, although we are having ongoing mapping projects, mostly as part of the USGS state map program, to change this. The superficial geology maps are those that deal mostly with the unlithified sediment at the land surface that some describe as soils. Note that this is a broader term than used in the video in this series that describes soil maps constructed by the USDA Natural Resources Conservation Service, and that distinction we will cover in a moment. Click on any map, say Palos Park. I think that's this one. Aha! That's southwest of Chicago. 2 maps are revealed down here at the bottom of the page. One created by J. Harlan Bretz in 1939, and a second created by ISGS geologists in about 2019. These maps are currently available only as PDF or printed products, although we are working on making the products readily available as GIS data. So now we can download the map, and you can see 2 pages. The first is a 2-dimensional superficial geology map, and the second provides a narrative explanation, as well as some illustrations about what's going on in the subsurface. So let me actually download this map. Prominent on the superficial geology map are the areas of different color. And also apparent are contours of land elevation, which are more concentrated where there is high relief, and spread out where it's essentially a flat surface. In addition are geological sources of geological information. All these little blue dots are water wells, and red dots are engineering borings. Cultural features such as the town of Palos Park and major roads, as well as lines of section. And you can see these as crazily drawn straight lines connected between various wells. The differently colored geological units represent different types of clay, silt, sand, and gravel, and diamicton, which is an unsorted mixture of clay to gravel, that occur within 5 feet of the land surface. And this is the main difference between superficial geology maps and USDA NRCS soil maps. Soil scientists are generally concerned with the soil properties in the upper 5 feet of the land surface, whereas geologic scientists are generally concerned with soil properties from 5 feet and deeper. These different geologic map units are parts of the soil toolkit, and each has different infiltration capacities. To the right of the map is a column that describes what the different colors mean, and these maps are stacked by relative age from oldest, this is bedrock, to youngest, disturbed ground. As an example, the map shows 2 yellow units. I'll need to zoom in. Here is a lighter yellow unit with the label C and a darker yellow or mustard colored unit with the label HM. If we go over to the column, we can see that C represents layers of sand, silt, and clay at the land surface. And these layers are typically less than 15 feet thick, and are interpreted as sediment deposited by rivers over the last 15,000 years or so. In Illinois, we give this the stratigraphic name of Cahokia Formation. By contrast, the mustard-colored pattern, labeled HM, is found down here. It is coarser, it's sand with some gravel, and can be much thicker, up to 55 feet thick. It is also interpreted as stream sediment, but from streams pouring out of glaciers before glaciers left the area around 16,700 years ago. These sand and gravel deposits are given the name the Mackinac member of the Henry Formation. Other extensive areas on the map are shades of teal. Those include diamicton or glacial till of the Wadsworth Formation and silty lake sediment of the Equality Formation. And these have various thicknesses from tens of feet to 100 feet or so. As I mentioned before, there are these lines of section on the map. They're labeled A to A prime. Here's A to A prime, going from north to south, and B to B prime. And B to B prime, for example, takes a haywire route from near Moraine View Community College through the community of Palos Park and ends up over near Crestwood. On page 2, you can see this line of section. This cross-section illustrates how we imagine the geologic layers below the land surface are stacked. We can see the land surface of the hills from the highest points near 700 feet down to the low-lying levels at 600 feet or below. And the very lowest unit is the flat-lying bedrock surface. In between are 2 glacial tills, these green colors, while inset into these are stream sediments, here with the sand and gravel pattern, as well as lake sediments, the silty lake sediments with modern streams set into those. The lenses of the yellowest units are likely most useful for green stormwater infrastructure projects. However, even the mixed to fine subsoils have a role to play in infiltrating water, although the size of the GSI would need to be increased for larger storms. And further, although the lowermost unit, the Hager member of the Lamont Formation, is a glacial till, it's distinctive by being quite sandy to gravelly, including lenses of stream sediment within it. Superficial geologic maps should be most useful in the early stages of GI planning. The maps can give people a sense of the range of subsurface soils that occur within their community. However, the map scales are intended for broader screening, and so communities do need to do local research. We hope that this information is valuable to your green stormwater infrastructure planning. Please do site work in addition to studying these archival data. This toolkit also includes videos on how to access USDA soils information, how infiltration rates can be measured, green stormwater infrastructure design, and more. Check them out.